Hello, next chapter is thermochemistry. We have concept of enthalpy. So these some of the learning outcome you should know, and also the important terms. We have heat, systems and surroundings, and also the energy. So we use SI unit, joule, or it can be the older unit, calories. There are two types of chemical reaction. We have exothermic and endothermic for thermochemistry. So we have exothermic reaction. Enthalpy is negative. The enthalpy of products less the enthalpy of reactants due to heat release from the system to the surrounding. So how do we get negative value enthalpy for exothermic process or exothermic reactions? So it comes from the formula enthalpy of reactions equal to sum of enthalpy of product minus sum of enthalpy of reactants. Since the system release heat, means we have enthalpy of product with lower value, and we have higher value for reactants. Lower value minus higher value of reactants, then we will get the negative enthalpy of reactions. This is energy profile diagram for exothermic reaction. You should know how to draw this energy profile diagram. Okay, you have y-axis labeled as enthalpy, x-axis reaction pathway. Alright, AB is a reactant, C is a product. So we have another one is EA. So what is EA, class? EA is a activation energy. How to draw the activation energy? Is start from the level, same level as reactant. Okay, enthalpy of reactant, and then till the peak of the curve. So that's a activation energy. So we have lower enthalpy of products, okay, compared to the enthalpy of reactants. Lower enthalpy of product minus higher enthalpy of reactants, then we get the negative enthalpy for exothermic reactions. So another one is endothermic reaction. Enthalpy is positive value. So the enthalpy of products bigger than enthalpy of reactant due to heat absorbed by the system from the surrounding. So when they absorb heat, enthalpy of product will be higher or bigger than enthalpy of reactants. So we use the same formula, enthalpy of reactions equal to sum of enthalpy of product minus sum of enthalpy of reactants. So since after the heat absorbed from the surrounding, the enthalpy of product will be higher. So higher number minus smaller number or lower number. So we'll get the enthalpy will be positive. Okay, enthalpy will be positive. So this energy profile diagram for endothermic reactions. Okay, enthalpy. We have level of enthalpy for reactant. This is a product, C is a product. So this is activation energy, EA. So how to draw the activation energy? Is start from the same level as reactant until the peak of the curve. Okay. For the endothermic energy profile diagram, the enthalpy should be positive since the system already absorb energy. So enthalpy of product greater than enthalpy of reactant. Thank you very much.